Just the other day, the system prompts for some of the biggest AI coding assistants was leaked on GitHub. It is literally thousands of lines of code that are very, very good and detailed, right? And so that's why these companies are worth the millions that they're worth in these products. It really all comes down to the system prompting that is being used in the backend. In this video, I'm not just going to explain to you how to write system prompts from a basic perspective. I'm going to literally break down the psychology of this. I mean, every fine detail of how to write an extensively high quality system prompt that is on par to be used in some of the biggest use cases you could think of, like powering AI coding assistant, whatever your use case may be. We're not talking about the 7-sentence one or 8-sentence one. We're talking about the ones that fill up the context window, and they're so good that the output that comes out of them is literally gold. Ladies and gentlemen, I put together a 40-page paper that contains the exact framework to write hands down some of the highest quality system prompts for AI that you can think of. And not only that, I included a detailed description of each component, the how and why of it, as well as the literal breakdown behind the literal psychology of high quality system prompting itself. I mean, this is not an ordinary system prompting breakdown right here. This is a deeper one that focuses on the small details that most people don't really talk about that actually matter a lot whenever you're doing system prompts. If you want the actual document to the framework, it should be in the description. Just look in the description and then you should see a Google Doc link. Go ahead and take it, follow along in the video. If you want to study it, use it for your reference, whatever you want to do with it, it's going to be. We're going to cover a real world system prompt together that is currently being actively used inside of a cybersecurity department. And as I go over this, I'm going to highlight the different components and how they play into the actual quality of this specific system prompt. And I'm going to also show you guys the good examples and bad examples of saying the same thing. Now, to show you just how effective this framework is, we're going to use it right now. And after I show you this right now, I'm going to dive into the full breakdown of everything that goes into it. I'm going to show you guys a quick hack to use this expert system prompt designing framework without actually dissecting all the meat of it. So first, what I want you to do is to head inside of this document, open it up, and we're going to copy the entire framework from the first thing all the way until the 15th explanation, which should end right above this psychology explanation. Once you have that highlighted, copy it. Then we're going to head into ChatGPT and open up a brand new window, and we're going to do something very, very simple. We're going to feed it this entire framework, and then we're going to ask it to create a system prompt for us using that exact framework. So I'm literally going to say the sentence that's typed right here, which tells it exactly that. Once I send that, it's going to say, hey, go ahead and send me that framework. And then what I'm going to do is I'm going to click paste and send that framework through. Now, once I send the framework through, after that, it's going to ask us, what do we want a system prompt for? So we're going to do this quick example for a legal AI whose job is going to be to analyze and dissect legal contracts and find any potential loopholes. So I'm going to tell that to it. Now, here's a little thing about using GPT that I don't think most people are thinking about. Let's say you're asking for an output that is extensive in length. Naturally, what's going to happen inside of here is ChatGPT is going to try to give you your entire output in one response. However, that is not optimal all the time. In fact, it ends up sacrificing length, which sacrifices the meat of the quality of the output that you would have received if it was longer. And so a way around that is to use the following sentence. We're going to say, I expect your final output to be longer than the context window. So once the context window fills up, ask me if we can continue. Do this until the output is fully outputted at its highest quality possible. And so after I say this to it, I'm going to click send right here. And what you guys are going to see right now is we're going to get this professional system prompt bone structure that we can use as a launch pad into whatever it is that we want to do. As you guys can see, this is covering every single component. And you are going to want to be tweaking this to your liking maybe, but at least you have a high quality templated base prompt that you can work with here. And you guys can see that the full context is not going to cover all 15 components. So it should stop before actually reaching the final one and ask us if we want to continue. So let's just go ahead and say continue. If I didn't say that, it would have outputted a condensed version that doesn't cover all 15 of them, or a version that maybe covers less quality than what it is that we're actually looking for lengthwise inside of each component. And so what we're going to do is we're going to keep going back with it and saying continue until we get all 15 of them. And right now we are at 11 with 2 different chat windows. We're going to go ahead and say continue again. And let's go ahead and hit the final one. This should be covering the full 15 after this, unless it decides to extensively dive into one of them, which I don't think it will do, but let's go ahead and see. And okay, awesome. It looks like it stopped at 18 sections. So with that being said, now we have a fully functioning system prompt for one sentence that we told to it after we fed it the entire framework. And you guys can see this is very, very high quality stuff. Now, if you're developing an AI automation and you have, one particular module, which is using some sort of LLM, the context window for these large language models is very, very big. So you have enough room to fit this entire system prompt into the context window training for this AI. So that way you can use this as its foundation for every single time it outputs something inside of that workflow automation system that you're using. So we're going to put them side by side here. On the left side, I have the actual framework, and on the right side, we have that example system prompt. So that way we can reference the framework while we break down the actual system prompt itself. Let's begin with the foundation of everything, which is going to be the role definition right here. This is not an optional thing. This is not a sentence that we're just adding for flavor. The role is the psychological anchor for everything the AI will do. In fact, every behavior that the AI exhibits, its tone, vocabulary, how it prioritizes details, how formal or casual it sounds, it all flows from how you define its identity at the start of a prompt. So when we talk about a role, we're not just naming a job here. We are giving the AI a mental framework, an identity that determines what kind of thinking patterns it should use internally to solve tasks. So if you say you are a helpful assistant, you're telling the AI to operate like a generalist, probably informal, probably vague, and definitely not authoritative. But if you say you are a senior cybersecurity analyst working within a global threat response team responsible for the live triage of vulnerabilities, you're doing something completely different. You're not just defining the function, you're defining state, you're defining urgency, you're setting performance bars. And this really matters because modern AI systems, especially large language models, operate by pattern matching. So they're not just guessing the next word, they're simulating the persona you described. And so whenever you define a strong role, you activate internal behavior changes in the LLM that map those expertise, technical rigor, and the actual delivery style. So how do you create this? You start with full sentences. Never fragment this stuff, right? You are onboarding this AI as if it were that senior member joining your team. You describe who it is, what domain it works in, what level of authority or seniority it's supposed to hold, what environment it operates in, is it government, corporate, etc., and what kind of thinking is expected, precision, caution, urgency. Every single word you choose here trains the AI's internal compass for that task. So you're defining not just who it is and how it should think as well. So let's break this down further. Suppose you're building an AI that responds to zero-day vulnerabilities, like this one right here. If you say you are a professional cybersecurity researcher, by itself, that's weak. It's not really wrong, but it's shallow. It doesn't really imply what kind of thinking the AI should use. It doesn't give it a mission context for that. It could write it in a way that a blogger would instead of an engineer would. Now contrast that with what we have here, right? You are an advanced AI system acting as an elite professional grade cybersecurity analyst and incident response specialist. We're telling it what it is and exactly the profession and what it's supposed to be doing, right? We're saying your role is to analyze breaking information about newly discovered vulnerabilities, threats, or incidents. So we're telling it what it's supposed to be doing, and then produce an expert level operationally useful response that offers clear, precise, actionable defensive guidance. Now it knows its role, it knows where it's at, it knows the expectation and the actual bar for performance. So it says you are a trusted core decision maker tool by a cybersecurity department. We're telling it where it's supposed to be, tasked with securing live high value production system. That's that performance bar. Your output will directly inform real world defense actions and must therefore meet the highest professional and technical standards. What we did right now is we took this AI and threw it inside of the mind of a real world cybersecurity analyst that is performing at those levels. So all of its internal thinking is going to be steered by that. And this is why it's going to make its role the foundation that's solidifying everything else that comes after it. So a properly constructed role definition basically makes everything that comes after it stronger. It prevents the model from defaulting into generic assistant behavior. It locks it into the mindset of a specialist, and it also helps constrain the AI's language model space. So without a defined role, the model might pull tone and structure from unrelated examples that exist. But with this strong role right here, you're basically fencing the model into a way of thinking that fits that professional domain that it exists in. So there's one last point here. Never outsource role complexity to the rest of the prompt. So don't assume the model will assume its identity from the context. Say it upfront in full sentences with explicit tone, scope, and behavioral expectations. So the stronger your definition is, the fewer surprises you're going to get in that output, and the more consistent and usable and professional your AI system is going to behave. So once that role is locked in, we're going to move immediately to the second most important part of this prompt, which is the objective declaration. The objective is not a single request. It's not a line that says, give me an answer. The objective is basically a contract between the system and the AI. It defines basically what the task is, what success looks like for our job. Now, folks, here is going to be our objective declaration. Let me just go ahead and brush over it very quickly. So we're telling it what's going to happen. It's going to receive a task. It's going to be given the title of cybersecurity related articles and the links to them, which are going to be talking about vulnerabilities, exploits, or security issues. It should go through those and fully understand them and determine whether a fix or mitigation is mentioned. It should then generate a full, detailed, technically rigorous response that enables a real team to respond correctly and completely. Then it should retrieve or first, actually, it must retrieve and read that article deeply, and then the comprehension of the article must be complete and accurate. So if the article includes a fix, patch, or mitigation, it needs to extract that solution in its own words and present it professionally written in a step-by-step remediation guide. The output must assume the reader is an experienced professional or a system administrator, and it should never simplify or dilute the technical path. Now, all of this serves a deeper purpose right here, which is calibrating the AI's effort level. When you explicitly state that this output is going to be used in live production environments or by teams that are in these domains, you're giving the AI a reason to prioritize depth over speed, accuracy over creativity, and completeness over conciseness. Because LLMs don't just respond to words, they simulate intent. So if you tell it the output is going to be read by executives, they're going to simplify. If you tell it it's going to be used by engineers fixing a production level exploit, they're going to be deep. And so another critical point here is your objective should scope the task. Don't leave it up to the model to decide whether it's a detailed playbook or a high level overview. Say it directly. Generate a fully implementable technical fix, or provide a structured remediation strategy and include fallbacks. These phrases anchor the model and the level of output fidelity, and it should never simplify or dilute the technical path. All of this serves a deeper function, which is calibrating the AI's effort level. So when you explicitly state that the output is going to be used in live production environments or by teams making operational decisions, you're giving the AI a reason to prioritize depth over speed, accuracy over creativity, completeness over conciseness. Because LLMs don't just respond to words, they also simulate intent. So if you tell them the output is going to be read by executives, they're going to simplify. If you tell them it's going to be used by engineers fixing a real production issue, they're going to go deeper. So another critical point here is your objective should scope the task. Don't leave it up to the model to decide whether this is a high-level overview or detailed work. Say it directly. Generate a fully implementable technical fix, or something like provide a structured remediation strategy and include fallbacks. These little phrases anchor the model's output for the fidelity that you need. And finally, always write the objective as if you were assigning this task to a human expert on your team, not to an assistant or an AI. Define the use case, the tone, the standards, the boundaries of responsibility. A strong objective declaration removes all uncertainty about the task, and it tells the AI not just what to say, but how serious, useful, or complete the answer needs to be for yourself. So this section alone right here, when well written, can multiply the quality of your output by orders of magnitude. So now that the role and objective are fully defined, the next step is to guide the AI through its internal reasoning flow. And this is where we move into something called process instruction. This is not about what to output. This is about how the AI should think before actually producing that output. So you are designing a simulated cognitive process, a mental sequence that this AI must follow to complete its assignment in a structured, professional, and intelligent way. So without these instructions, the AI often skips critical steps and it might rush straight into an answer. It might summarize instead of analyzing, or it might hallucinate logic because it hasn't been told to slow down and do things in phases. So what does that actually look like? Well, it looks something like this. We're telling it first to retrieve and deeply read that article, and then we're telling it that everything must be complete and accurate in its analyzation. And then we're telling it that this article includes some issues, fixes, and patches that are discussed, which it should extract and reconstruct the solution in its own words. Then we're telling it to present it as a complete, professionally written, step-by-step remediation guide for an enterprise environment. That's important. The output must also assume the reader is an experienced professional or a system administrator, and it should never simplify or dilute technical path. Folks, this is not just a to-do list. This is a thought model. You are explicitly teaching the AI to move through a series of stages. 1, ingest that information. 2, analyze and interpret. 3, evaluate the completeness. Conduct external research if necessary, and then synthesize and construct. So this mimics how a literal skilled human would approach this task, and that's the whole point. Language models simulate reasoning through pattern emulation. So if you tell them just to provide a solution, they're going to jump to output generation immediately. But if you define a step-by-step mental journey, they follow it. They simulate introspection, analysis, and synthesis. and they tend to produce significantly better and more complete results when doing that. And another key when writing process instructions, use full sentences, not imperative bullet points. You're not programming a function, you are onboarding an intelligent agent into the system. So the more natural and human-like the instructions sound, the more natural and human-like those instructions sound, the more reliably the model will simulate a thoughtful and organized cognitive flow for that. So let's take a practical example. Say you're asking the AI to analyze a vulnerability article that you have. If you don't include the process instructions, the model might skim that article, jump to a half-baked summary, skip checking if a fix is included, fail to conduct any external research, or it might return an answer that sounds nice, but it lacks real depth. But if your process instruction says something like, hey, your first responsibility is to extract a full understanding of the vulnerability, identify dissected systems or methods of exploitation, potential impact as well, and then I want you to determine if the original article offers a reliable fix. If it does not, you should investigate the most recent mitigation strategies from credible sources, and only once you understand those are complete should you construct a professional remediation step. So this forces the model to emulate a much deeper and analytical chain, and crucially, it's going to constrain the behavior of the model to mirror high performance work. And this is especially important whenever you're dealing with technical, high stakes environments where the process really matters just as much as the output. Now, there's also a psychological layer here. Whenever we're instructing the AI to proceed in phases, we're not just guiding that behavior, we're telling it to respect the complexity of that task. And so we're implicitly signaling that this is not just a generate a text job. This is a multi-stage thinking job, and the AI responds to that. So in short, this process instruction is going to be your way of embedding intelligence into the workflow. You're literally hard coding mental discipline into the AI's simulated cognition. And when you do that right, the output that comes out on the other end is way more complete, way more thoughtful, and way more aligned with how real human experts would operate when actually completing the task that is at hand for this AI. So with the thinking process now structured, we're going to shift our attention into how the AI should communicate the result of that thinking. And this is going to bring us to one of the most critical parts here of any high performance prompt. And then it's going to be the output structure specification. This is where you teach the AI how to organize its response. Now you are no longer dealing with what the AI knows or even how it thinks. You are now controlling how it speaks, how it writes, how it builds a professional document from its internal conclusions. So if you don't define this structure right here, you're pretty much gambling. The model might give you bullet lists or a casual paragraph, a fragmented outline, or even worse, just a wall of text with no logical breaks, no hierarchy, and no real sense of document coherence here. So a great output structure here, it basically acts as a skeleton. It holds that entire response together, makes it readable, trustworthy, and immediately usable. So the goal here is two things. First one is to eliminate randomness in the output, and two is to standardize a professional structure across all the use cases for it. So let's break it down here. First, always instruct the AI to write in narrative form using full paragraphs. Unless whatever you're wanting it to do demands technical steps into it, avoid top-level bullets and never let it fall back on a generic outline template unless you specifically tell it to. The reason why is because paragraph-based narratives forces the model to connect ideas, creates cohesion. It drives the model to explain not just what to do, but why and how, which is essential in high-value environments, such as the security right here, or compliance, or medical documentation, whatever it may be. Next, we're going to explicitly define which sections should appear in that output. For example, in this context of the cybersecurity response, we might say something like, hey, you should then transition immediately into the comprehensive solution section. This should offer a full mitigation strategy and include configuration changes, vendor updates, and also, if multiple solution paths exist, make sure you include those, as appropriate. Now, in this case right here, we give the model a hierarchical layout, a beginning, middle, and an optional end, each with a specific function. So we're not just giving the AI a writing task here, we're handing it a content architecture, and that changes how it prioritizes, filters, and formats every sentence that it actually writes. Another important aspect here is depth perception. Don't just say include a solution. The model's going to understand this is an overview when you say that, and that is going to give you performance constraints. Say something like no shortcuts, no high-level guidance. Whenever you say that, you're locking the model into using professional complete material. So let's talk about one of the most powerful things you can do in this section is something called preempt drift. And that's when the model starts really strong in the beginning, but it loses structure halfway through or maybe towards the end of its output. You can prevent that by saying things like maintain the same structured format throughout your response, or like do not change output or style between different sections. Each section should begin with a one-sentence positioning line and then expand into technical explanations. This keeps the model even focused more on longer outputs that comes out of it. And just to summarize this, really we include this section because it improves the legibility of that output. It makes that output much more functionally useful in a real organization. And so whenever you do this right, this makes that output indistinguishable from the output of a actual person that will be doing it, which is exactly what high-level prompt engineering is about, is so that way we can rely on the output of this AI in a level that we would rely on the same output as somebody else doing it. So with structure in place, the next piece of the system prompt focuses on how the AI should sound. This is the section that controls the tone, the language style, and the actual communicative persona of the AI. It's called tone and language guidance. And if you want consistent, high trust output, this is very important. It's basically, it's not just decoration. It leads into the confidence and the intent behind the actual output that is delivered. So if your AI sounds too robotic, too casual, vague, or overly templated, even if the response is good, it might lose credibility because of that tonality of it. And so how do we configure this? First, the tone control must be explicitly stated inside of the system prompt. Don't assume that the model is going to know what that is based on what it's doing. You have to define it in clear language as part of the instructions it has. For example, you might say something like, your tone must be direct, authoritative, and professional. You are writing to an experienced cybersecurity operations team, and I want you to not use casual phrasing, filler in conversation, or generic words. Write as a senior practitioner. Write in a confident and operationally focused manner. This thing immediately frames the voice, tells the AI what to sound like and what not to sound like, what to emulate basically. And there are a few different components into tone control. The first one is formality. This refers to the formality level. So in a professional environment, maybe you want the AI to operate at higher formality, no slang, whatever it is. Or maybe you do want it to talk in non-formal ways. Then you might have to define what that looks like in here. Number two is going to be directness, especially if it's a critical or a safety-driven task. Maybe you want the AI to use declarative sentences to avoid speculative language like you might want to consider or a possible approach could be, unless you maybe doesn't actually know and you do want it to say that. And the third thing is going to be fluency. So maybe the output should be like a human expert written from scratch. That means fluent sentences, natural transitions, and not just a stitched together sequence. This is achieved by really explicitly telling it to write in natural language, not to write in fragments, right? Write in full sentences in clear narrative structure. This is what is going to give it that transition, that cohesion in the way that it's actually delivering what it's supposed to be saying to whoever's supposed to be reading it. And number four, the fourth thing is stylistic consistency. One of the most overlooked issues is something called drift. The output might start off professional and then slip into casual phrasing halfway through. You can prevent that by saying things like maintain a professional, consistent tone throughout. Do not change voice or writing style mid-response, even across different sections. This ensures that the output reads like a single coherent output. Now, there's something called negative tone shaping as well, things that the AI should never do. And that's going to be saying things like, do not write in overly robotic phrasing. Avoid vague generalities. Do not introduce rhetorical fillers, such as it is important to note that unless you needed to. Eliminate ungrounded optimism, vague encouragement, or empty affirmations. Things like that are important because LLMs are trained on a huge text type. Blogs, chats, marketing copy, technical manuals, social media, all of that stuff. If you don't box in this tone, the model will occasionally pull from the wrong domain that it was trained on. You're going to get answers that sounds like content instead of sounding like decisions. And in professional environments, that stuff really matters. Another important function of tone guidance is audience targeting. You have to instruct the model who the intended reader is. This affects vocabulary, assumptions, and depth. For example, if the audience is an executive, you can say write with strategic clarity, minimize jargon, and focus on impact and risk. If the audience is a technical person or whoever it is, you can say write with technical wording, include exact configurations, operation controls, and threat models. The more specific the audience description is, the more tailored the AI's language becomes. So you're not just telling it what to say, you are teaching it who it is speaking to and why that person will care. Now, this next section is one of the most critical ones, and it's also one of the most ones that are neglected in prompt design. This is the behavioral constraint section. It defines what the AI is not allowed to do. Think about this like the boundary layer of this system prompt. You're not just telling the AI how to behave, you're literally defining the red lines for it, the failure points, the shortcuts that are forbidden for it to take. Large language models will often default to least effort plausibility if it's left unchecked. And so that means short, safe, and vague answers that sound okay, but maybe offer a little usable substance for us. So this section right here is how you block that behavior explicitly. And so how would we actually use this? Well, one of the first things you can do is to tell the AI to avoid being brief. You can say things like, do not provide short or superficial answers. Every response must contain a full explanation, context, and a step-by-step detail where it's applicable. Do not assume the reader or infer anything that is not explicitly stated. This will remove the AI's tendency to collapse complex responses into two-line summaries, which is something that it often does when uncertainty is high or when the input is weak. The next thing you might want to do is to prohibit vague phrasing. So you don't want responses that are going to say, you may want to consider, could be helpful to, some experts believe. These sort of phrases are really hollow, right? They're not committal. So instead, you'd want to instruct the AI to avoid vague and speculative language. Every recommendation must be specific, actionable, and grounded. And if uncertainty exists, describe it precisely and explain the implications. Another issue you might want to target in your system prompt is the external references issue. Models love to say things like, check the official website for more information or more details. And that might seem helpful, but in performance system prompts, it's actually not really reliable. So your prompt must tell the AI something like, do not defer to external links or documents. If a fix or a process is mentioned, reconstruct the solution in full detail or do research for it and then let me know instead of this response. Assume we must take action only with the output you provide. A sentence like that alone would significantly improve the output of this quality because it removes the AI's ability to outsource the work back to you, the user. Another common issue that you might want to target is the temptation for the model to summarize. And that usually looks something like, the article discusses vulnerabilities and it's suggested that overall the main point is blank. That's really a summary. Now, apart from these two common things, most other behavior constraints are custom to your situation. It literally could be applicable in so many different ways based on what it is that you need done. And so the main concept here is to think about what you do not want in that output. Write everything down in a list and then come up with this. Oftentimes you're going to end up using a version of the prompt that you think is good, and then at some point it might output something that you don't like. So then you would go back to the prompt and then make a change that adds whatever behavior constraint that you noticed in that output and you didn't like. So in this example here, I went through specific constraints that apply to how this department right here wanted the final version of that security report to actually look like. And so you can see here, like, don't skip over unclear or unknown details, don't rephrase article content mechanically repeated, avoid stating that a fix is simple because, unless it truly is, and then don't produce high-level summaries. We already talked about the summaries. There are a few more down here, but then usually this is going to be particular to your specific output and how you want that quality. Next component we're going to talk about is handling uncertainty and edge cases. So here's the reality. In real-world tasks, not every input is going to be perfect that's given to it. Sometimes the source material itself is just incomplete, outdated, or incorrect, or incomplete. So if you don't define how the AI should behave in uncertain situations, it's going to guess. And oftentimes that guess is what leads to hallucination, filler, or just wrong recommendations. So what you do in this section is very simple. You have to know what information is missing and what edge cases happen, and then you instruct the AI explicitly on how to react to those. And so in this example, you can see we told it if the article does not provide clear up-to-date fixes, it should conduct autonomous research using credible sources across the internet. So this is a clear direction that says, look, if you run into this situation, this is what you do. And so the key here is pretty much knowing what these situations are and what they can be. Literally sit down and brainstorm, list them all down, and then come up with how your system should react whenever these things come up. And it's literally as simple as that. So by giving it fallback logic, you're ensuring that even in bad conditions, the AI remains useful. It doesn't freeze and it doesn't lie, right? It adapts with transparency. That's the big piece here. And also, this is the section where you're really protecting against hallucinated responses. You don't want the AI to act like it has the answer in the output when it clearly does not. If you're dealing with time-sensitive knowledge or need responses that need to be up to date or at least in recent times, you have to pay attention to this section right here, which is temporal awareness and freshness enforcement. What does that mean? The reason why this is important is because without these pieces of instructions, the AI will often default to its training data, which could be months or years old. And so if you're building an AI system that reacts to vulnerabilities, for example, in this case, or whatever it may be, that's not really acceptable to go back and reference old data. So this is where you need to actually inject this into the prompt. And you're explicitly telling the model, hey, I do not want what was true last year. I want what's true right now. So you begin by stating the priority clearly, saying that you want favored the most recent and up-to-date information available. Prioritize fixes and mitigations published within the last 30 days, right? Saying something like that causes the AI to surface newer knowledge in its searches and in its knowledge, especially in areas where its browsing capabilities is allowing it to synthesize external inputs in real time. But even if the AI cannot fetch live data, this piece of instruction will still bias its internal completion logic for more recent patterns of discourse in its training. Also, temporal awareness dives directly into source prioritization. So what does that mean? It means you might want the model to value content from different types of sources more than others. For example, research papers versus Reddit communities. Maybe you want everything that comes to you to be only from credible sources. And so this is essential because the internet and even the AI's internal data that was trained on is littered with stale advice that looks correct, but no longer actually applies. And so if you don't embed a preference for this, the AI might default to outdated material that might sound confident in its response, but it's actually irrelevant to you. You also want to address something called time drift. And what does that mean? In this example for the cybersecurity, let's say a model found something something that worked 3 months ago, but in the meantime, the issue evolved. We have new exploits, or the vendor might have changed how they respond to this exploit. So you want to guard against this outdated information by saying something to the AI, something like, when finding a solution, indicate whether it remains current. If the fix is older than 30 days, confirm whether it has been superseded or challenged by a more recent strategy. Or something like, always provide the relevancy date and relative age of the technique that is known and that was referenced. So saying something like this adds a temporal fingerprint to the model's logic for it to consider the life cycle of the information that it's finding and not just the content of it. At this point, the AI knows who it is, what it needs to do, how to think, how to write, and how to stay current and relevant. So now we arrive at one of the most cognitive components for expert level AI behavior, and that's going to be research and synthesis instruction. What does that mean? This defines how the AI should gather, validate, and consolidate external information that creates new valuable output. And this is especially valuable for systems that require clear and thorough consolidation of the information that AI gathers from external sources. It's about cutting through the BS and making sure that this output is delivered as we expect it. Let's start with a principle here. Say we expect the system to do some sort of consolidating of information. We know that the backbone of that is not about collecting, it's about constructing them. And so that's the psychological shift that we have to encode into the AI. So we don't want the model to behave like a search engine. We want it to actually act like a senior analyst, somebody who scans that information, filters through the noise, and is able to build a coherent response from all of that messy information environment. So to do that, we have to begin by instructing it where to look. So we do that here by using this verbiage, saying things like prioritize trusted sources such as this one and this one and this one and this one. This kind of verbiage right here literally creates a source preference map. The AI now knows that credibility matters, and so certain sources in its mind are going to carry more weight than others. So this helps suppress clickbait level content from entering the synthesis layer of the actual output that comes from the AI. Then once you include that, you have to include what the AI should avoid. And so what does this do? This defines the difference between high value signal and low value noise, which is critical in open research task systems and information consolidation ones. So in this prompt, we did it in several different prompts, but here I highlighted one of them for you guys to read. Next, after you do that, you have to instruct the AI on what to do with what it finds. So you don't want it to just copy those quotes. You want it to synthesize. And so that means combining different pieces of information into a single, clean, implementable output, which should be written in the AI's voice with no referencing of the outside text fragments. And so saying things like, your goal is not to merely collect, but to distill, validate, and professionally re-articulate. This creates originality under constraint. So the AI becomes a communicator and not a mirror. And that's what makes the final output actually feel like a professional document rather than a stitched up summary. So we've told the model the different weights behind the different types of sources. So now what we want to do is we want to have it internally label the status of these sources. What does that mean? This primes the model to qualify its own statements based on how stable, authoritative, or risky the information from the sources. So it basically prevents the model from treating different types of sources that are not on the same level equally in its own decision making whenever it comes to the information that's being pulled from the sources, right? So here the goal is to have the AI basically be able to differentiate between sources and then prevent it from mixing things like official guidances versus unofficial fixes and speculative ideas. So think about information from official sources versus information from some random Twitter page. So if you don't include status labeling, the AI might find a piece of information from that random Twitter page and then find another piece of information from an official source, and then it could potentially give you only the one from that Twitter page because it has no real sense of equivalence between the different sources that it's pulling its information from. And so we do that here in this prompt, in this highlighted section. We can say that if during your research, if you encounter unofficial community developed mitigations, include these with clear contextual labeling. So this works to distinguish between official patches available from vendors and workarounds recommended by communities or temporary fixes under discussions. Here we emphasize that all research content must be embedded in its output. And the reason for that is because we don't want the AI to say there's a fix on GitHub. We wanted it to actually bring that fix in here. And so we say things like this highlighted piece of the prompt here, which forces the AI to convert those findings into usable output. This removes any risk that the user would miss something critical because they had to follow a link or interpret some sort of raw data themselves. So whenever you do this section here correctly, it would turn the system from a passive summarizer into an actual synthesis engine. It would read, validate, and organizes just like how a real human doing this kind of research would do. And folks, this is basically what professional grade prompting is about. You're not teaching the AI to sound smart. You're not telling it to be smart. You're teaching it to think, filter, and deliver in ways that would match the same standards of a real person doing the same type of work. Now we've arrived at one of the most advanced and underestimated parts of the system prompt design, which is embedded quality assurance behavior. What does that mean? This is where you teach the AI not just to generate the output, but to critically evaluate its own output before presenting it. Large language models don't actually know if their responses are good, and so they don't have a built-in verification system unless you built one into this prompt. This section is how you simulate a self-check pass, where the model reviews what it produces and then actually corrects itself before it returns it to the user. So the goal here is not to make the AI perfect. It's basically to make it act like a confident human professional who doesn't hit send without actually reading their own report and their own work. And you would begin this section by explicitly instructing it before finalizing your output, review your response. Check that all instructions are complete, logically structured, implementable. Don't implement partial or vague or unfinished sections. Saying something like that tells the model, don't just click send, review first. And you can also trigger specific verification loops of quality checks inside of the prompt by embedding micro audits inside of the embedded quality section. So let's go deeper here. Look, each of these acts as a checklist. The model would reprocess the output that is just generated using one of these behavioral patterns that you embed into it. For example, you have this error check-in one, which would look something like this in this example. Do not allow summary sections to appear where full implementation guide is required. Identify any area where you provided high-level advice and replace it with detailed step-by-step instruction. Simple enough, right? But believe it or not, folks, this tells the AI where it most commonly fails, and it preemptively corrects that behavior. You can also force a form of self-interrogation. For example, ask yourself, if a cybersecurity engineer followed these instructions, would they have everything they need? If not, expand the guidance until it meets that standard. This is called metacognitive prompting. You're modeling the inner monologue of a professional who holds themselves accountable for the completeness of this work. And so another critical instruction that you can include here is one about assumption detection. Something like scan your own output for implicit assumptions. Wherever a step depends on an unstated condition, such as prior configuration or context, make that dependency explicit. What does this do? This helps reduce those dangerous cases where the AI writes something like apply the patch, but fails to mention that this patch only works on version X or requires a restart. So you're training the model to detect those logical gaps on its own. And then you have edge correction. This is when the AI fixes its own shortcuts. Take a look at this. You can say something like recheck whether you, and then here you would insert something you don't want it to say or do. Then we can maybe also do that here. And then if so, rewrite those sentences with whatever description or instructions you want instead. This prevents any unwanted phrasing or actions by the AI. So you're telling the model to replace those by some other directions. And why does this really matter so much, right? Because the quality of an AI's first draft is only part of the equation. Without this review layer embedded, even the best model could produce incomplete, structurally broken, or just non-detailed outputs. But with an embedded quality assurance layer embedded, the model becomes self-correcting. It's basically the same reason why humans use checklists, peer reviews, or postmortem feedbacks. We're fallible and so is the model. But when you teach it to pause, check, and revise, the final result is dramatically more reliable. At this stage, your system prompt is nearly complete. The AI knows its role, objectives, how to think, how to write, how to research, how to avoid failure modes, and how to review its own output. So now we bring it all together with one final component that basically locks in discipline and it reminds the AI what's at stake. This is the final framing and use context section right here. This part is short, but it's powerful. It delivers the closing message to the AI, which is basically a psychological reinforcement that everything that it produces matters and that real-world professionals would rely on it. So in here, in this example, we do that by saying, always remember that your output will directly inform protection of real systems. Every task is a mission-critical advisory. The idea behind saying something like this is that large language models don't have intent, but they do simulate intent based on what you tell them. And so whenever you say, this output will be used by security teams to make decisions that affect life systems, you change how the model evaluates its own answer qualities. And this changes the model's self-calibration threshold. It becomes more conservative about vague claims. It becomes more rigorous about instruction quality. And it becomes more consistent in tone and structure because now it believes its work has consequences. And so this is more than just raising the standards for it. It's about aligning the AI's mental simulation with real-world professional responsibility. All right, folks, I genuinely don't think I could have gone any deeper with the psychological explanations behind the large language model prompting.